might hear some thunder.
Hello, everyone. This is Scott Roberts with Explore Scientific, and we are here live today with Jerry Hubble. Let me bring Jerry on. There we go. Today and for the rest of this week, it will be just Jerry and I talking to you. Kent is involved in some special training right now, and so we need to give him time to do that. And so anyhow,
That's great that we're able to help
yeah,
improve
yeah.
skills and knowledge. You know, that's part of the business, right?
That's right. It's a big part of the business, you know, and you have been very instrumental in raising the bar of our technical knowledge, you know, and so, you know, and we're going to talk about some of those aspects today. We're not going to try to be too technical with you. And if you have any questions as we're going along, you know, please chime in. But, you know, operating a computerized control system for a telescope is not simple, you know, so.
No, just 30, 40 years ago, this was just, you know, government agencies and engineers and scientists do what everyday people do today with equipment.
That's right.
You know.
That is absolutely right. So we have, we're on episode 34 at this time, and we are, so we're going to talk about the evolution of ExploreStars, the app. I know that you wanted to talk about some of the other technical aspects. We were just discussing it. Jerry, what was that?
Yeah, so one of the things was I wanted to do a quick thing about failure modes and effects analysis left over from yesterday. I did just a little 3 or 4 minute thing to show you one of the detailed analyses that we do for Exos 2 mounts. An example failure modes and effects analysis for the mount. And then also I wanted to talk about, let me go to my desktop and see what it was. Oh, the programmer's reference manual. I want to do an overview. Now, I'm not going to get too into the weeds with that, the programmer's reference manual, but I want to make people aware that it's out there, and it does have a lot of good information that we try to explain how the system operates, and it gives you a good fundamental understanding of what the system is designed to do. And that kind of goes back into yesterday's program for troubleshooting. It's a good reference for that, and I wanted to go over that also, not at a fairly high level. And if people have specific questions, of course, we can answer that. But so I guess we'll do the I'll do the failure modes and effects analysis form real quick first, and then we'll get into the programmer's reference. Or do you want to split that up and go into the
well, let's talk about the
ExploreStars
first and kind of where it started.
Yeah, let's do that first. Let's do that first, and then I'll get into the other stuff.
Yeah. So ExploreStars started with us thinking about the state of go-to systems that were out there for amateur astronomers to begin with. You know, where we had proprietary software controlling that's operated with a hand controller. Okay, and you know, we were already seeing people controlling their telescopes remotely. There was a big need for people to use planetarium programs to control their telescopes. There was a giant shift as we were starting to see it with people setting up their own remote observatories or remote backyard setups, that kind of thing.
Right.
Um,
Using laptops for their control
right,
system,
right.
not just the traditional hand controller. Everybody wanted to use ASCOM. Now, ASCOM's been around for 20 years, but only the last 5 to 10 years has it really become a big thing.
Hmm. Right. And so uh, it quickly became apparent to us that fixing in the features and operation of a go-to telescope was that no one could actually really keep up with the pace properly. Okay. It would require a large base of programmers to come up with every nuance and every specific need that amateur astronomers would have. And so uh, I thought a lot about of whether I would have our new go-to system be a proprietary system, or I would open it up so that a community could drive it. And it seemed like the right answer again and again was, we're going to let the community drive this and come up
Right.
with connections, with features, whether they were just asking for it or whether they were actual programmers that could design it. So
Right. Right.
and now with our OpenGOTO community, now is this our second year of
The
being
forum's been, it's 3 years. The forum's been up.
years? Yeah.
Yeah,
So
3 years. So
it
one of the
started.
things with this architecture, right? One of the things with this idea that Scott had, he wanted to open up the system, is we had to really think about what architecture lends itself to providing an open system, you know. It turns out, and I always knew this before, but in terms of being able to be flexible and to be able to have increased performance and margin, we needed to get rid of the monolithic standard hand controller that has everything built into it. We
That's right.
needed to separate these features out so that we could quickly update the features that needed to be quickly updated. And also on the other end, on the other side, where we want reliability and performance, we need to make that as stable a platform as we can get. You don't want it all glommed together, because then you never have a stable system, basically, if you're always wanting to update it.
That's right.
So we separated all the architecture of our system is basically what we came up with. Is it's a motion control system that's abstracted out all the astronomy specific stuff out of the hardware. And now it's been abstracted out to generic general purpose computer system, whether it be a tablet or a PC or a phone. All that stuff has been brought out to that level. So now we can do changes quickly and efficiently at that level and provide and keep up with technology. Technology is increasing performance and increasing needs of people are growing every year. So that was why we architected the
Oh
system
yeah.
like it is. That's why the PMC-8 is designed as it is.
That's right. That's right. I mean, even you think of computer technology and operating systems and all of this stuff, it's evolving at such a rapid rate that I don't think any one small company could keep up with it properly. And I believe that companies that try to, and they try to do it with the small amount of resources that they have, they really can't support the customers very well that way. And
Right.
so much better to have the community itself embrace it, drive it, develop it, and then work with our own team to vet what's going on and to and provide education about how to use it, and so that you can evolve that system to serve it in the way that you want it to be served. And so that's really the idea of it. And we've talked about this before, Jerry. It used to be that this hobby, once upon a time, was about maybe grinding your own mirror, building
Oh
your own,
yeah.
and look, those are great things to do, but the things that people do more of these days is they do their own programming, and they've learned how to program. And so
Right.
a lot of kids, my grandsons know something about programming now. And so
Well,
that,
something else has happened over the last 30 to 40 years, probably the last 30 mainly, is the growth of the consumer astronomy hobby and the manufacturers and vendors that are out there to provide equipment. Back 40, 50 years ago, you were used to building your own telescope, and then vendors and manufacturers came about to where you could buy your telescope. And then in the 90s and 80s and 90s, then you became people that built or that created companies that created accessories for your telescope. And then people started to get into the hobby more, say, oh, I'm just going to buy this from this vendor and that from them. And then they became system integrators
yes, they did.
as opposed to manufacturing stuff themselves. Although today there's a kind of a renaissance in the manufacturing area where you have 3D printers where people are building accessories for themselves now with 3D printers.
That's right.
But that's
That's
a small piece, but now you've got hundreds of vendors that provide equipment that you integrate into your own system design, and you buy the best of what we used to call it in the nuclear field. It was the best of the industry pieces, the best of whatever people offered. You bought that and you integrated it. Yeah.
right. So,
So, hmm
right. And so, I think eventually a lot of as you said, a lot of hardware will be 3D printed by the users themselves. They'll get pieces, that they can 3D print in a variety of materials. Some of the really super expensive printers today print in metal. I've mentioned on a previous show going to take a tour of SpaceX and seeing their titanium 3D printers that they have, where they print filters for the rocket fuel. It's just stunning what they can do, and those are $1 million machines right now, but in the future, probably machines like that will just be a few $1,000s. Because machines that were a few $1,000s before in the 3D printing world are now hundreds of dollars.
right,
So
right.
who knows? Maybe at one point they just give you the 3D printer and they make their money from the materials that they sell you to 3D print with.
Right, right, exactly. There may be in the future an open mount design where people can download the 3D printed mount system
Yes.
and have it and either print it themselves if they have the equipment or send it off to a third party
Yeah. If
3D
you want
printing house.
something done, sure. Sure. It'd be like sending out your film to get processed and get prints made, right?
Right, we already have that today with the electronics. People design and build their own custom electronic systems and make small manufacturing runs, prototype runs
Mm-hmm.
uh, to do that. So we're in a maker world, basically a do-it-yourself maker world. If you have
Sure.
the will to go do that work. I mean, it's exciting possibilities for individuals to create their own products and to start businesses,
And
basically.
our businesses. That's right. So
And that's a big thing in this country. Manufacturing has left the United States, and I'm going to be U.S. centric here, but
you
the rise of manufacturing, personal manufacturing, has come about.
sure. But it's not only US centric. I mean, let's say that you live in, I'll pick a country, for instance, if we export product to some countries in South America, the import duty, VAT, can sometimes double or more than that the selling price of this product. So in some countries in South America, I mean, to buy a telescope that would cost $500 here cost over $1,000 there. Okay, not in their dollars, our dollars.
Our
Okay?
dollars, right?
Our dollars. And so you got the problem of the conversion rate and all the rest of it. And good Lord, if they could take design files, maybe buy design files, from someone that's really talented and print up their parts, that would be also something that. So those are things that we see on the horizon. Of course, people will always want a fully integrated, fully dialed in, fully warranted, type of
Right, turnkey system, right?
right. That's right. But
And so we have to cater to both ends, basically, both sides. If we want to be a full service manufacturer for our customers, we want to be able to offer what people want,
that's
right? That's the goal.
that's right. We're here to serve.
Mm-hmm.
We are here to
That's right.
serve. And so we've
Mm-hmm.
digressed talking a little bit about 3D printing, but this is really in the same vein of talking about letting people develop on the control system that controls their telescope and controls their experience and
Right.
give them the data that they want, whether it's a beautiful image or, in the case of like the Mark Slade Remote Observatory, the data that they need to detect an exoplanet. So that is that's the fundamental philosophical basis of the ExploreStars system and the PMC-8. When we started this program, we were working with Dan Dickerson, who came to us and said that he could develop an application, a remote application, okay, or a wirelessly operated system to control our mounts. And so we did some initial work on an existing board.
Mm-hmm.
And we demonstrated that this could indeed work out. Dan won from Microsoft a design award for his application. And at that time, it was developed for the tablet because Windows phones were not very popular at that time. Windows tablets were of course, very popular. And so he developed the whole thing on a Surface tablet. And so that was the initial product. We then moved on to developing for Android, and then eventually on for the iOS platform.
Right. Right.
And so some people who are now coming in new to our community and didn't see us where we started are going, well, gosh, why didn't you guys develop the iPhone and Android phone version first? Okay, and this is the reason why. So what I can tell you is that we are, in fact, developing on those for the phone systems, but it just the way it all
Right.
started.
Right. There's a couple of other reasons we wanted to experience. Well, this was the first mount product for Explore Scientific that was developed from scratch. And we wanted to incorporate the ExploreStars app that Dan had developed. But to make the user experience easier, we wanted to develop it on a display system that was big enough to show everything we thought the beginners would need to see on the display and be able to control the system without having to deal with the small real estate that a phone gives. And this was, remember, this was developed right back in 2013 is when I first got involved. So it's been 7 years ago. It's not
That's
like today where we have these bigger phones and all the other stuff. The phones have advanced quite a bit over the last 7 years.
that's also true.
So it's kind of the context of what we have and we only have certain resources to do these upgrades. We only have certain amount of effort that we can put into it, and we have to maintain our legacy stuff, but also be able to bring it forward. Uh, and we're doing that. But again, I think a lot of times people have the perception that we have a lot of resources that we don't really have. Maybe it's because of our performance as a company and the service, that's maybe part of it.
Well, for instance, at Mead Instruments, we initially started with one programmer. Okay, he developed the LX200 system. That was the first closed loop full go-to system that Mead had, and that was developed by an outside individual. Okay, Tom Melsheimer developed that system, and eventually we started developing it in-house. We moved from the LX200 system to not a system we called AutoStar. Again, it was all a very proprietary system and everything. John Hoot worked with a programmer that worked in office. John was, again, an outside contractor working for Mead Instruments. But eventually it was really, the brainchild of John Hoot and developing on that system. And he did some amazing work and everything, but Mead was still, the philosophy is that we've got to keep this, we got to patent this, and we got to sue other individuals who try to copy it. And
that's expensive, isn't it?
You look at what it costs to patent something, and then a patent's really worthless to you until someone copies you. You have to have someone copy you, and then you have to fight it in court, and then you got to win. Okay, and if you win, that gives force to the patent. Up until that time, there are no patent police running around saying, hey, wait a minute, you can't do that, it's patented. Okay,
right.
Now, if you are someone that is copying a patent of any kind, you are treading into a territory where you're likely to get into a court battle. Okay, because that's what it's all about. And the millions of dollars that were spent trying to defend the AutoStar system could have been much better spent developing new technology. Okay, more support for its customers, just a bunch of things, because it cost millions of dollars. And in the end, what happened? They settled out of court in mediation, and it just was not the real result that the founders of the company had intended. So that's and I thought, gosh, I don't want to be in that situation.
No, we want to turn it 180 degrees around. We want our customers to build the system they want and help feed the environment, the ecosystem for the whole project, for the whole product.
And who are we to dictate what the system should absolutely be? There are research institutions like Lawrence Livermore Labs, for example, and NASA and universities and stuff like that would like to take a precision motion controlling type of system and develop it for their own needs. Okay, so while we have people involved in our OpenGOTO community that are using this, there's no telling what really the PMC-8 is being used for in research or industry, where we'll never hear about it, because it's something that is proprietary to them, and so, and that's fine. That's fine. That
our goal is to provide it as an excellent platform to build applications on, is what our goal is.
That's
and to help our customers succeed in whatever they want to do with it.
That's right. So
that goes back to the phone. So the question on the forums that's been discussion is why, and beginners come into this, say why, like you said, why don't we have a smartphone app already? That's an obvious question.
Sure.
If we were to start this today, let's think about it this way, Scott.
Yeah.
If we were to start over and wanted to build an open system,
yes,
we would probably build our first app on a phone, I would think.
Oh, sure. Of course.
I think that would be the case.
There are probably more phones out there now than there are tablets by a long shot. Okay. So, you know, I have
So, right. So the
laptops, I
experience,
have phones, I have everything, but some people just have a phone.
right, the experience would be different than what they have with a tablet. It'd be totally different. And so we still have the goal of making it easy for beginners. And you'll see that in the phone version of the ExploreStars app. And I think people appreciate that. We're one of the other issues we face as a small company is what do we include in the application? We don't want to reinvent the planetarium program. There's lots of them out there. They're freely
Great
available.
programs out there,
We do
right?
not want to recreate that. We want to add value where we can and make it easy for our customers to use and take advantage of third-party tools and applications.
Right.
So
That's
that's where we're at. That's the other philosophy that we bring to the table. That's why people, eh, think about how many hundreds of thousands of dollars it would be for us to create a brand new planetarium from scratch.
and how many years it would take to get
Right,
as good.
right,
Okay.
right.
The other ones that are out there. Okay. And that's
We
providing
face that, right.
and improving.
We
So
faced that with the mount control system. We were late to the game. We were very late to the game.
yeah,
These systems have been out there for 20, 30 years.
that's right.
But we had a brand new approach. We had state-of-the-art technology. We thought we could at least match or leapfrog the performance and that was our goal anyway of what's out there in the industry. And I think we built a platform that can do that.
I think as far as reliability that we did leapfrog the competition, you know, so um, we rarely hear of a system that has failed. You know, I wanted to, we'll talk about Gary Palmer
Oh
uh,
yeah.
later on. He's been on our show. You guys know who he is. He delivered a beautiful image of Comet Neowise. But
I've got it up if you want me to
well,
show it
yeah,
real
let's
quick.
look at it. Let's shift gears here a little bit.
You see it?
Oh yeah, this is a stunning image. He sent
I'm going
this
to zoom
to
up a
us
little bit.
yesterday, and in fact, he just made this image yesterday. He told me today that he's busy processing a better version of this, and um, so you know he's got some cloudy nights right now, and he's getting some rest, and he's got time to do that image processing. But I think it's spectacular just the way it is. You know, the ion tail structure that
Yeah.
you see there going way out there, and then the dust tail. It's a
Oh
beautiful
yeah. It's
kind of
great.
yellow gold color. You know, it's really very nice. And then this blue green comet head, you know, which is you know, just spectacular. It's one of the best Neowise shots I've seen so far. This was shot on an Exos 2 with PMC-8, and you know, some of you might have heard that Gary is testing some of the cameras that we're looking at. We're evaluating now for Explore Scientific. So Gary's one of the top astrophotographers in the world, and you know, he turned out a very nice image. He told me that the camera was had a 10-meter long USB cable, which is not designed to work with the 10-meter long. I mean, it's like 30 feet of
Yeah, that's pretty long.
cable going to your computer. So, but anyhow, that's you know, so that's a great image. So I had called Gary today just to congratulate him on his image, and he said to me, he said, "Yeah," I said, "It's great." He said, "I did want to bring your attention that that I had a problem with the Exos 2." And I said, "Oh, really?" You know, and so I immediately called Jerry, and we got online with him. And you know, Jerry was able through Zoom. We used the Zoom platform. He was able to get into his computer to figure out what was the problem. And so, how did you resolve it, Jerry?
So his problem was that he was trying to he had previously used the Exos 2 and connected with ExploreStars fine, it came up like always. And then today, this morning, he got onto it. I guess it's this evening for him, but he got on it and it would not connect. And he tried it with another tablet and it wouldn't connect. And then he tried Ascom wireless and it wouldn't connect. I said, what the heck?
What's going on?
And he tried it several times, of course, and then he called you and then he called me so what I want to do is when I troubleshoot this problem, I want to go back to basics. Okay.
Mm-hmm.
So I wanted to make sure that my initial thinking was that I wonder if the controller itself died. You could connect to my Wi-Fi module, but the controller wasn't responding correctly. So it was never making a connection or telling the system that, yeah, I can communicate. So I asked Gary to go ahead and put it in serial mode. He was able to do that through the configuration manager. So he had the configuration manager already up and was messing with it, trying to figure out what was going on. So I had him go ahead and do that, and then I got on Zoom and I did a reset the connection,
Yeah.
sent a command to show the version of the firmware. I sent the ESV command manually in the advanced tab on the configuration manager, and it came back. So I said, oh, good, the controller's working. It's running. It can receive commands. So then I stopped that, and I had him, and I switched it back to wireless, and then he brought up his tablet, and it worked. So this is sometimes typical when I get involved with a problem.
Yeah.
It's the machine seems to be scared of me for some reason, and
It's like you're
and it
going,
knows better.
you got,
It's like my kid. It's like my kids.
yeah. And then you go to the doctor and there's nothing wrong.
It's kind of like my kids when they're acting up and I start to say, you better, I need to understand what you're doing here. And they say, oh, I'm acting fine. I'm okay. Don't worry about me. So it gets worried about getting looked at. I don't know, but it's just an odd thing. I've seen it happen a few times like that where people will have issues and Gary wasn't doing anything wrong. He was just
No,
doing the
of
standard
course not.
stuff.
And Gary is a very experienced
Yeah.
comes to telescopes and drive systems of all different kinds, all different brands. He does reviews all the time for the magazines. And so, very, very experienced person. So,
So it may have been something with the wireless module got hung up. Maybe the traffic environment was changed or something changed about it where it locked up the system for some reason.
so
And I got
basically,
on there and re-switched it back and forth between serial and Wi-Fi, and it knocked it out of its stupor, I guess.
mm-hmm. Yeah. So
Mm.
maybe one day we'll find out why there was a stupor. But,
Yeah, I don't.
it
Mhm.
kind of goes back to my experience with IT guys in companies. You got like something wrong with your desktop and nothing's working, and often they just say reboot. you know,
Yeah, exactly.
reboot.
That
So it's kind of, we almost
mhm.
did a reboot today. So
Right.
um,
But it's working. I mean, you might have I know a lot of people have similar intermittent problems like that where they'll be using it for a while and then all of a sudden it'll act up and not work all of a sudden. And it could be a couple things. It could be they've got their sequence, when they went back to run it again, they forgot a step in the sequence of starting it up, or they did something extra that put it in a different way of mode or something that caused it to hang up. There's a lot of different interactive pieces. That's the whole thing. There's a lot of pieces running to make this thing work, a long chain of events that have to happen
that's true.
to come together. It's a complex system.
Yes.
It's not like a mechanical focuser where you just have a gear and a knob, that's very basic and simple. It's not like that at all.
Right.
But if it works, it works, and it either works or it doesn't. That's the way I look at it. If any piece of this is working, like for example, I did that test to make sure it was communicating, then I knew the board would work. There was no doubt about it. So, you
Right.
know, so you
Right.
could do some high
Well,
level tests.
I mean, I would, sometimes I have these, I call them internet moments. Okay. And then for me, this was an internet moment because here we are, we're thousands of miles away from Gary. Okay. We're able to log into his system dig around into the configuration, make a reset, and fix the problem, you know, and we did
Right.
that in 10 minutes.
It's
Yeah,
5 or 10
5 minutes,
minutes.
whatever it
Yeah.
was. Yeah, yeah. I mean, we had
Yeah.
more fun. We talked longer and had more fun just kind of talking with each other.
Right. Exactly.
But he's up and running again. So, you know, so that's the success of that kind of thing. And that is just only something we could have dreamed of. You know, if I'd had a closed off, you know, AutoStar type standalone type of system, we couldn't have gotten into his telescope, you know.
No, the only thing you could have done is just ship him another part
Yeah, ship another hand controller.
and wait a week or two for him to report back and say, "Oh no, it's not the hand controller, it's something else." Okay, what else is it?
Hey, so it had to go overseas, had to go through customs, would have had to, you know, it would have been a month before you had it, you know,
Yeah,
versus
that's
us fixing it in 10 minutes, you know, so.
right, right. And that's something in the future we're going to be building forward. That's going to happen more and more for our equipment into the
That's
future.
right.
We're going to be able to provide much better support, much quicker support as time goes on.
Yeah. So even faster than 5 or 10 minutes, it seems,
I know.
yeah, but
Well,
in the
but
future,
if
5 or 10 minutes will be like an eternity. Okay.
but if you're up in the middle of the night, you know, and you can't
Oh,
get a
yeah.
hold of somebody, then you rely, you know, there are other systems that might be available in the future that will help you out.
Yeah. So let's look at some comments here.
Yeah, who's on the line? I was going to ask
Oh,
who.
we got Dusty Haskins on, Astro Beard's on. Those guys are on Twitch. We've got Bergman Scooter, Chalks, Ansel Puri, Caesar Brolo's on, Jim Norwood, Darren Drake, Phil Creed, John Adler, Nico, Bill Black, yeah, and Hazari Ha. Okay. All of these are on Facebook right
Oh,
now.
cool.
Yeah. And we don't have any viewers on, or wait a minute, maybe we do have some viewers on Twitter. Yeah, we are on Twitter as well. And then on YouTube, we got Mr. Thump 30, Deep Sky Dude, Wolfgang, Andrew Corkhill, who worked with me at Mead Instruments.
Oh, okay.
Yeah, yeah, he's got an Explore Scientific telescope today. Deep
Cool.
Sky Dude is on. So let's see what James the astrophotographer. It's fun to see you guys on here. Michael Whitaker.
That's quite a few people.
Yeah, right.
I
Yeah,
want to challenge everybody that's online too. I want to challenge everybody to try to bring a friend, to invite somebody to watch with them
yeah, that's cool.
virtually, you know,
Right,
or to tell people about our our show, you know.
right. Yeah. So some of the things I'm thinking about for kind of a special show is maybe interacting with some of our viewers that are set up this way to have them come on Zoom with their system and to show us what they're doing. You know.
That'd be awesome. Have them share their desktops and their cameras so we
Yeah,
can
yeah.
see
So
what
they
they
got,
how they configured their system.
that's right. That's right. We
That'd
can
be
do
awesome.
pretty easy to do. We would just send you a Zoom invite and you would share your screen. So if you guys are interested in doing some of that, let us know. That would be great because I know many of you can do that. Let's see. Some
Any
comments.
any comments? Yeah.
James the astrophotographer thinks that's a great idea. James, why don't you email me? My email address here, I'll give it to you. It's s@ explorescientific.com. Okay.
Yeah, you know you're the big boss when you just have a one letter name ID on your email. S. I
Just
want to
at.
talk to S.
That's right. That's my initial. That's
It's
my
not
initial.
spelled ES. Well, that's kind of cool. ES is spelled ES, right? Explore Scientific. So
Astro Beard comments. He says, when I'm at home, Oh, wait a minute. He says, I have heard, Dusty says, I've heard that anything over 15 foot can cause issues. I just carry my laptop around as I'm sewing because the longest one I have is 10 feet. That's his. And the Astrobeard says, when I'm at home, the command center inside powers the mount outside by battery, and the laptop interfaces with Thunderbolt 3. I'm not familiar with that. But using a separate cable for cam allows me to pass laptop through the window and be able to focus. Okay. That's almost remote, you know, when you're
I
passing
ran that.
through a window, you know.
Yeah, right. I ran that way with a long USB powered USB cable when I did remotely. I used to do that.
Yes. Astrobeard says, oh yeah, even when I use a DSLR, I use a live view flip screen or Atomos Ninja. Okay, but I only image with the DSLR in winter because the noise I'm normally using, because of the noise, I'm normally using a ZWO ASI 183 Pro. Okay, that's a nice camera.
Oh. Mm-hmm.
Yeah, yeah. So, and then on Facebook, what do we got here? Who would we gripe at when we couldn't get the software to work? Well, you would gripe at us. So
we're responsible.
Yeah, we're responsible. So we'll help you figure it out. That's coming from Jim Norwood, you know. So
Kent does that work quite a bit. He does
oh yeah,
he basically does that. That's his full-time job.
Yeah, that's right. So we're happy to get you going. Other comments. Jim Norwood, I'd be happy to share a photo. Can you help me with the clouds? Maybe if we set it up, Jim, the clouds will just part and then we can do it. So you just never know. Bergman Scooter wanted to know if it could have been battery voltage problem with
Gary?
With Gary Palmer. What do you think?
I don't think so.
Could it have been like a spike or something that?
No, typically the battery voltage really impacts the motor itself. And if you see your battery voltage getting low, the electronics will run because it only runs on 3.3 volt logic. So the motors run on 10 volts.
So it's funny here. Mike Overacker wants to know what the S stands for. Scott, of course.
There's other words that could apply maybe.
Or letter word, I guess, but you know.
What does S stand for?
Says, I don't understand what S isn't number one at explorescientific.com.
Oh, I'll have to get that one.
Nico says the one. Okay, that's too many letters, guys. I'm trying to reduce how many letters I have to type in. Oh, that was actually a 3D printing comment about who you would gripe to. Oh, gosh.
Oh.
I don't know who you would complain to about that, you know. Just
okay.
In the general population, someone will pick up on it. So, but anyhow, you know, yeah, that is true. You know, if guys are 3D printing their own things and then it doesn't work, who would they complain to?
Themselves. They didn't either read enough or they didn't think enough hard enough. You know, there's something that was lacking there that caused, but that's the learning experience. You never learn anything doing it right all the time.
That's right.
You have to make mistakes to learn something.
That's right.
And I've made
your own mistakes so that you can become more brilliant in the future.
Right. So believe it or not, I've made a million mistakes doing the stuff I do.
No.
Otherwise, I wouldn't know as much as I do, right? That's the only reason I know enough, because I've made millions of mistakes.
That's true. Billions of mistakes.
Billions and billions, like what the.
Right. That's right. Well, okay. So
we could go on to this back to a little bit about what we were talking about yesterday. Do you want to do that, Scott, where I can
Yeah.
do a quick overview of one of the last things I mentioned yesterday was a formal program to understand how things will fail, and it's called a failure modes and effects analysis. And I just want to show a document that's an example of this with on a problem with the Exos 2. That's a real quick thing. I don't want to spend a lot of time on it. I just want to do it so that we get it on video so people can go back and refer to it and look at some of the things that we think about when we troubleshoot a problem. So I'm going to share my screen again, and I'm hoping to get this up without making a mistake here.
But if you
Let's
do make a
see.
mistake, it'll make you better in the future.
That's right. Well, I got it right.
Too bad.
All right, so this is a form that I created as an example. When we're doing our product development, this is some of the engineering discipline I'm trying to bring to our industry and our company in particular, in terms of being able to understand our products a little better ahead of time. And so one of the things I did an analysis, this was after the fact, of course, since we already have the PMC-Eight Exos 2.
Mm-hmm.
What is the failure is excessive lash. Okay, what is that? And there's assumptions that go on with this failure mode. The amounts required torque does not exceed the provided motor torque, which means that there's nothing wrong with the motor or the electronic system in this analysis. And any errors in pointing are physical in nature, which means it's related to alignment. It's not related to the actual mount quality per se. Okay, those are the two things. So, for example, there's
Now,
different parts.
Terry, how did you arrive at these assumptions?
Uh, Based on my experience, I wanted to restrict the analysis to a certain area. So I
Okay.
had to think about, if I just want to look at the mount itself and the gear system and stuff, what things have to be correct, and there may be three or four more things that have to be correct, or four more assumptions or something. But these are the main ones
Okay.
that helped me bound this analysis. It helped me keep it to this level at this in terms of the components in the mount itself. So the things we look at, we have an item, we have the actual problem, we have the function of the component, we have the failure mode of the component, we have predicted causes, not predicted, but you know, causes that we think that might to
Inferred
that
cost.
failure, that may lead to that failure. And then what are the effects of the failure? And then we have a mitigation strategy. How do we protect from getting that failure? So I get a little technical with my language here. End effector is kind of a fancy term. I don't, this
I
is my own internal type stuff.
got a T-shirt that says end effector.
Yeah,
Yeah,
end effector, right?
that's right.
Let me go to a good one here. Let's
Everybody.
say this is a good one. So the if we the component in the mount is like the rod extension axis pulley, the grub screw that tightens the pulley onto the shaft.
Okay.
All right, that's basically what this is. The screws that fix the large and small pulleys to the RA axis, right here, right?
Right.
And the failure mode could be a screws not tight, causing pulley to turn independent of the shaft. Okay,
Right.
that could either be a manufacturing defect.
Right.
Okay, we delivered it that way. It could be temperature induced loosening,
Right.
or it could be, if the user did some maintenance, it could be failure of the user to properly tighten it.
Either by the user or by us.
By us, that's
Somebody
right
didn't
too.
do it right.
So the effect of that is that the shifting of the pulley independent of the shaft, causing excessive lash or failure to drive.
Right.
So this is what you're, so this is the pain right here. Like I said yesterday, this is the pain that can be caused by this component
Right.
not being correct. And then so to mitigate it, you basically properly tighten it to ensure the pulleys are locked in the
Right.
proper position.
Now, these kinds of things, and if you read each one individually, it's kind of like you go, yeah, that's logical. You know, why even?
It may be obvious.
Yeah, obvious, right? But and
Mm-hmm.
why even write it down? Why even write it down? Because this is just something that you can just check and do. You know, but the thing is that there are so many points in manufacturing a mount or manufacturing a telescope or any of these parts and these components that you as amateur astronomers work with every day. Okay. If you don't look at these things and start to try to isolate them and document them, you know, you repeat the same problem again and again and again.
Right, exactly.
And Jerry said that he's trying to introduce this into our industry because I can absolutely guarantee you, you know, when most telescopes are being made, a lot of the knowledge of how these things go together is it's tribal knowledge. Okay. It's because this guy taught that guy the next one on the line. Okay. And
Right. And there's special stuff in there. There's a lot of
don't tighten it too much, don't tighten it too little, make sure you use this, make sure you use, and I know it says this on the print from the engineers, but this is how you assemble it, okay, to make it really work. You know, there's a lot of that stuff goes on. And so by having a template like this and for us to identify it and then share this back with manufacturing, okay, we start to close the loop of these problems and of any kind of problem that might exist. And so, you know, this goes to a pair to list of problems and solutions, and you start to develop the discipline of documenting it and reducing problems. You can actually never really eliminate problems.
The other thing is,
this never happens,
that's
you know.
right. But the documentation also gives you good training material.
Right. That's
That's
right.
the other side of it. And it just it ensures that you think these things through to make sure the design is correct when it goes out the door. Because we don't ever want to run into a design problem out in the field. We
Sure.
really do not.
That's
That's
right.
costly. That's very costly.
It is. It is very costly. Not
And
only from our standpoint, but also from the customer and losing their time and losing the enjoyment, you know, because they are investing into their enjoyment and gratification, you know.
right. So I get into this covers both design problems and broke fix type problems. So for example, I don't want to go into this. I'm ready to move on to the next thing, but this is an example of our tooth design.
Mm-hmm.
You know, is our pulley tooth correct for what we're trying to use it for? You know, the design of the pulley tooth should ensure lash-free operation, right?
Right.
That's a major design goal.
That's the assumption. Yeah.
And the failure mode is that the incorrect tooth design is causing engagement issues, which show up as PE errors, which is what we actually have identified that. So that's an area of improvement that we need to think about going forward. If we identify these issues in the field where you have like the PE error in our pulley system is caused by either belt tension or maybe it's the tooth design, but this could be a design defect based on our choice. Um, this is, you know, this is as real as it gets here. This is some of the things that we run into and we've documented.
Mm-hmm.
So I talk about that here, tooth design issues leading to PE.
Right.
So in our future designs, we want to try to do the best we can to provide a better design.
Right.
So that's another example of a design issue rather than a broke fix type thing. All
Yeah.
right. So
The
are there any
whole
questions?
process,
Anybody
the whole
question?
thing is a in quality control. There are companies that uh, drive their quality control to a level. In fact, you will sometimes hear people in manufacturing, if you wanted to go, if you travel with me to China and met some of the factories and stuff, one of the questions that might come up is, well, what kind of quality level are you looking for? Okay. And
Right.
we're not looking for a level. Okay. We have a quality control target of ever ongoing improvement. Okay. So you look at things like maybe a pulley tooth design or something. How could it be made better? Is it different material? Is it a new mold? Is it just a completely different design? So those are things that just like one of these little segments down here would start to drive that. And of course, the better that we can make it, there's always an expense side of improving, but there's also a cost saving sides of fewer returns, greater
Right.
satisfaction, these kinds of things. So,
And
and
one thing that I think Scott hired me for was I've got a fairly extensive background with Six Sigma design, quality improvement systems, and Six Sigma design and process improvement. So that's another area that I bring to the table for our industry to continuously look at things and look at our processes and our procedures and try to make things better. And our defect rate shows it, I think, in terms of the PMC-Eight.
that's very
We
low.
have we have a very low, and you want to drive those down as low as you can get, because and I always talk to Scott and Ken. I said our goal in quality and service and in our customer support should be, we should put ourselves out of business. We should not get any calls from our customers. That should be our end goal.
Yeah. I want
Because,
the ag
you
repair,
know,
where he's just sitting there next to the phone,
right,
bored,
exactly.
sleeping most of the time.
That's
Yeah.
really should be the goal, because it's not that we wouldn't have customer service. It's that we want to reduce cost for the customer and provide the customer the very best product we could give them. Now, there's a large disconnect between reality and that, because we've got a large diversity of customers that have certain levels of expectation. We can't never do that, but that should be our goal, to provide the information and the tools necessary for the customer to really help themselves be successful.
Right. Right. At Explore Scientific, if I look at the people whose jobs are strictly dedicated to customer service, where you call them a customer service rep, we have 4 of them. Okay. My former company, we had a team of almost 20. Okay.
Mm.
And that's all they did all day long, each answering over 100 calls a day. Okay. It was a
A
madhouse
lot.
in
That's
that,
a lot.
so, and we are doing a wide range of products. We're doing rifle scopes, we're doing spotting scopes, we're doing binoculars, telescopes. We treat our eyepiece line as like a whole separate business, in the way that we develop it. We treat our go-to line as like a whole separate business. We have play structures. We're building tents. In fact, one of the new tents that we have going on right now is an observatory tent that we'll be showing here pretty soon. So, and we have to answer all these different kinds of questions, and we do it with very few people. But the other part is that everyone that works at Explore Scientific gets involved with customer service. Everybody,
Yeah.
all the way from shipping to people that answer the phone calls, like as a receptionist duty, to the engineers, to everyone, including myself. So
Yeah. Hmm.
yeah, we know where our paycheck comes from,
Yeah, exactly.
and the customer's the boss.
Yeah.
So we're
Uh-huh.
hoping we're making the boss happy.
That's right. Yeah. That's
Yeah,
our goal.
right.
It's funny when we get customers that ask us questions, or I don't know if it's the tone of the question or it's the way the question itself, but it sounds sometimes like they assume that we're out to make their life miserable.
Right.
and we really are not. As miserable as it makes you, it makes us 10 times as miserable because
Oh, that's
we're responsible for that at some level.
true. I can't tell you how many times I stood up all night long thinking about a customer and a problem that he might have with the gear, and how we were going to solve that and how fast we could solve it, so,
Right.
but that's really how it should be. That's how it should be. Daniel Sanchez has a question. He says, hello, Scott and Jerry. What type of tube is your favorite for planetary and deep sky observation? Could be more than one. What's your favorite, Jerry?
My my favorite telescope has always been a refractor. Uh, I did I worked with I have a Meade Schmidt Cassegrain I bought in the 1987 that I've had, you know,
Mhm.
forever. And I like that scope a lot. But I had to go back to a refractor when I got back into astrophotography because of the stunning pinpoint sharp images
It's true.
and when you look through an eyepiece, it's just awesome, you know. Even at high magnification on planets, you have to, they don't make telescopes as long a focal ratio or as large a focal ratio as they used to, of course. The typical one back in the 70s was f15, I think, pretty much.
Right.
Now we're dealing with f7, so now we have to add additional optics to be able to get the high magnification that we used to get out of the box. But that's fine because our technology today, our optical technology is way, way better than it used to be. And so when you put a tele extender on, a three times or a five times tele extender,
Yes.
does great with these scopes. I mean, for doing planetary and lunar, and it's just awesome. So my first love with telescopes and astronomy was lunar, was the moon because of when I grew up in the 60s. And I get into deep sky objects only because they challenge me with my equipment today. That's the only reason I really look at deep sky objects today in terms of photographing them.
Right.
Um,
Right.
hmm
I would say that mine is, well, of course, I love the refractor image too. But I started astronomy with a Dobsonian, a big, it was a 13.1 inch Coulter
Oh,
Odyssey, and big aperture. My deep interest starting out was after I'd read a book about the expansion of the universe from Timothy Ferris. It was called The Red Limit. I recommend the book to people today. It's just a great book. Um, and I wanted to see the fossil light of galaxies visually. I knew that you could see photographs of it, but to me, that was not going to be the same as actually having fossil light hit my eye, and hit my retina, and for that kind of connection that you get, and knowing that you're looking back into time, in real time with your own eyes, millions of years. And so
that photon traveled millions of years just for your eye.
just for your eye. That's right. It's a very special,
Yeah,
almost like a communion kind of thing, So people that love deep sky visual observing know what I'm talking about. You're in a, it's almost a religious experience. You are in this temple with the Milky Way overhead and all the cosmos, all of the destruction and creation and everything's going on right there in front of you. And to see it live is very special. Uh, Now, I also love photography, and so the astrophotographer in me, which admittedly I'm not I don't practice astrophotography like I wish I could. It takes a lot of devotion, a lot of time. But I'm always in awe of the great astrophotographs that come from the amateur community, and I'm also in awe of the science that's being done by the amateur community. It's just it's a thrill every day to sit here in this seat and see what's going on around the world with people using our equipment and other people's equipment too. Just that ingenuity that amateurs
yeah,
have. So what do I think that you need as an amateur astronomer overall to have a full rounded experience? I would recommend a good refractor. There is visually or astrophotographically, it is one of the best instruments to observe that pinpoint star image that Jerry's talking about. But also when you see nebulosity, it looks like it's etched out of crystal. It's just incredible, and people get addicted. Refractor owners get addicted to this kind of an image. Getting big aperture, the biggest aperture telescope I've used in a refractor is a 40-inch. Having used the 40-inch refractor at Yerkes Observatory with Explore Scientific Eyepiece was a big thrill for me. And those images, I can shut my eyes and I can still see them. Okay, really amazing. But the big reflectors are also very, very impressive. I've used the 60-inch at Mount Wilson, the 100-inch at Mount Wilson, and the biggest scope I've used is the 200-inch at Palomar visually. So, just a fantastic experience to see something collecting light so far away and to actually see color and stuff. And visually is just a huge thrill. But as an amateur astronomer, I think that it makes sense to have a big Dobsonian, because you can do that organic astronomy. I think it's great to have a refractor sitting on a computerized mount, so that you can visually look through it, gets breathtaking views of planets and deep sky objects that are within the range of the aperture of your refractor, and then to go beyond that range with a great camera system, so.
I think a good, if you're a rank beginner where you're just starting out learning in the sky or learning in the hobby, I think binoculars is really a best choice.
That was the other thing that was on my mind too.
I would suggest getting, now it just so happens that a binocular are two refractors next to each other, but that's just neither here nor there. You're not going to see the deep sky objects, but it'll get you started in understanding optics and what the sky looks like looking through an optic.
Right. That's right. So, so let's jump into your programmer's reference, Jerry.
Yeah, this won't be very long. We're already past an hour, so I just want to do an introduction for everybody, and I want to ask people to not be afraid of it. This document, it is a very technical document in certain areas, but it also has a lot of great information that can answer a lot of questions. Pretty straightforward questions. So let me go to the browser real quick and I'll show you where you can get this thing. So if you go to support, PMC-Eight software and downloads.
Okay.
Then you scroll all the way to the bottom. I kind of hide this thing at the bottom because most people aren't that interested in it, but it's available at the bottom of the page. You'll see here, click here to download the PMC-Eight programmer's reference. So that's where you can find it. So let me go back to the
And why
document.
should people, do you think, should take a peek at this?
Well, so in terms of what we've been talking about the past couple of days, in terms of troubleshooting issues,
Yes.
it helps you to really get a better feel. The sections I'm going to point out to you are at the are at the front of the document, and it's really the introduction to the system and the system description on page, and it's only 2-3 pages. It's not that much information, but it gives you a good overview of what the system does and what it and what's involved with it, and tells you some specifications about it, how it was designed, what it's designed to do. It gives you a good overview of the system.
Mm-hmm.
It
Right.
shows you kind of what the processors do, the microcontroller. It gives you a picture of the system. Talks about what components are there. This is more technical, but it gives you a good idea of what it is, what the system actually is. And so that's why I suggest people read that. And then there's the next part of the information deals with booting up the system and what you can expect. Okay, at a certain level. And then this is a big thing right here, the status indicator lights. You're sitting there looking at that thing flashing at you
What it's doing. Yeah.
like a robot. What the heck does that tell me? What is it telling me? And then you can report the problem maybe a little more accurately to us. You can get an idea of what it's doing or what it's not doing.
Right. Yeah.
And then I talk about the fundamentals of the system, basically the description of how the system works, what's involved with switching channels, you
Well,
know.
this whole thing is going to let you intimately know what your controller system, the heart of the controller system is doing.
Right. That's right. And maybe give you some insight into what's going on with the system in terms of where it's at when you push a button on the ExploreStars app, you know what it's trying to do, and you know kind of what the components are being used at that time, like the driver chip on the board. So for example, on the let me go back here. So this is what the driver chip looks like. Each motor has a driver chip, and it impacts the operation of the motor. So if you have, for example, if you have a little bit of stuttering, or if you have the one motor working and one not, and you have to understand this driver chip requires a certain voltage to drive the motor. Maybe your battery's low.
Right.
That's kind of gives you a little bit of insight on why that failure occurs the way that it does. Why does the motor start to act weird when the voltage goes down? Or what is that an indication of? And it's because of the battery voltage. And then you'll say, oh, that's why. That's kind of the thing that I'd like people to, if they're going to troubleshoot their own system and learn more about their equipment, then this is a thing. But I talk about some specific things, how things work. And then I get the theory of operation for the controller and the command language. And you can get into all that stuff, but I just wanted to introduce this document to people to not be afraid of it, to
Sure.
go and download it and just look it over. And, you don't have to, I don't expect everybody to understand everything about it for sure. But
Right.
you may see a term or a phrase in there and say that raises a question in your mind. Oh, maybe that is related to what I saw. Maybe I should ask Jerry about this. Is this what's causing that? That's the kind of thing.
Sure.
And then
Well,
if you're a programmer, there's the meat and potatoes in there that detail the specs on the language that to control the mount. So that's this later part here. So for example, um, a set command, set axis position value. Okay. What that actually does, that's how the sync commands work. We basically tell the mount where it's at and we reset the motor position. So that's an example of knowing how the thing works. So that's for programmers.
right. So let's see if we have any more questions. One of the other things I kind of reflect on when I see this document, though, I wonder, okay, what if my iPhone came with such a document and I understood everything about what the iPhone is doing? Would I be that interested? Maybe not, because
Right.
my iPhone is really, my hobby is not on my iPhone.
Right. That's right. That's not your
I use
hobby.
it, it's a convenience thing, okay? But if your hobby is astronomy and you really are interested in your gear, well, a lot of companies won't provide you this information, okay? We do, so that you can understand the philosophy of how the product was built, the philosophy of our ongoing improvement, that kind of thing. And maybe you don't understand electronics, maybe you don't understand some of the programming references, that kind of thing. But certainly we can give you a peek under the hood and you can start to check out what it is. And it's just a philosophy of transparency. So that's
Right.
what's
Right.
behind all that. Okay. All right. So why don't we stop sharing your screen there for a moment?
Okay.
I did want to just to have the two of us on here. I wanted to have kind of a shout out for Chuck Ayub. I don't know if you guys all of you guys know who Chuck Ayub is, but if you go to Chuck's astrophotography on YouTube, you will see a series of wonderful videos that Chuck did. You know, we got to know Chuck because he started making in succession, I guess, several astronomy pictures of the day on NASA with his Explore Scientific telescopes. And so he sent me a message, and he has announced on YouTube that he's going to take a break from his astrophotography, and that he was hoping that people would stay subscribed to him. You know, I want, you know, I have known several very, I mean, amazing astrophotographers that have applied an intensity that it takes to be amongst the world's best. Okay. And, you know, you can only do that for a number of years before you have to have a retreat, a recess to.
Your passion drives you to learn everything about it to get to this level, and then you're trying to get to the next level, and you understand that you need a break to recover your resources to
That's right. You have to
get there.
reflect on all the things that you learned. You know, I mean, you're studying the universe, you know, and so even that, just the focus that you spent on imaging the universe, all that stuff, I think it requires some time for you to step back and think about, okay, what was all this stuff? You know, what are the things that I discovered and that I studied, you know, by going pixel by pixel, looking at individual stars and studying the structure of nebulosity and galactic arms, and trying to go as deep and as hard as I could to you know, get the images that are, you know, blow everyone away. So you know, that I think that you have to sit back and reflect and absorb on that. So you know, we encourage all of you out there in the community that love astrophotography. Those of you that have watched Chuck's videos know that he's got, you know, a great sense of humor. He really shared a lot with us, more than most astrophotographers do. You know, so I think he carried a tradition of that's great amongst amateur astronomers to share the knowledge that they have. And so, um, so you know, that kind of concludes our show for today. You know, we loved all of your questions and your comments, and we'll be back on tomorrow. It'll just be Jerry and I, and you guys have a great night, and
Yep.
we will talk to you later.
Yep. Thanks, everyone. I appreciate the time.